Exercise 38, question 2. This is a very common engineering scenario where you would use simultaneous equations to find current flowing in a circuit. And if you look at work problem number 13 on page 75, you'll see a very similar one worked out for you with the circuit diagram. So how do we go about doing this? Well, we've got two unknowns, I1 and I2, the current flowing in the circuit. So let's call those equations 1 and equation 2. So we've got two unknowns, two equations, so we can find them. Before we can do that, though, we just need to use algebra to tidy up these two equations so we can get two simultaneous equations that look familiar to us that we can then go about solving. So in equation 1, I would expand out the brackets and then collect together like terms. In equation 2, I would expand out the brackets and again collect together like terms. So see if you can carry on from there and work it through. The solution though follows. So from equation 1, multiplying out the brackets, so I've got 0.2 I1 plus 2 times I1 gives 2I1, and 2 times minus I2 gives minus 2I2. Collecting together I1, I've got 2I1 plus 0.2 I1, so I can write that 5 equals 2.2 I1 minus 2 I2. You might want to write this the other way around so it looks familiar. 2.2 I1 minus 2 I2 equals 5. And that could be equation number 3. See if you can do a similar thing and arrive at equation number 4. I'll have a go at it now. So from equation 2, we've got that 12 equals 3I2 plus 0.4 I2 minus, multiplying out the brackets, 2 times minus 2 times I1 is minus 2I1, and minus 2 times minus I2 is plus 2I2. You have to be a bit careful about signs there. Collecting together like terms, I've got 3I2 plus 0.4 I2 plus 2 I2 is 3.4, 5.4 I2. Minus 2 I1. Again, writing those the other way around, we've got 5.4 I2 minus 2 I1 equals 12. Let's call that equation 4. So now we can try and solve them. Let's put them together. Let's rewrite number 3 underneath, 2.2 I1 minus 2 I2 equals 5. That's equation 3. What we need to do now is make I2 or I1 the same and solve by elimination, or rearrange equation 3 or equation 4 to read I1 equals something or I2 equals something and then substitute in. I suggest the easiest thing to do is to multiply through by something to make them the same. I'll pause it here and then you can have a go yourself. The solution will follow. Okay, so the problem is to try and make them the same, isn't it? So if we look at I2, we've got 5.4 I2 in the first equation and 2 I2 in the second equation. So what do? Well, one way to do it, probably the easiest way to do it, if I multiply equation 4 by 2 and equation 3 by 5.4, then I will get I2 is the same, because using the idea that to take any two numbers, say 2 and 3, then a common denominator making them the same is if I multiply them. What's 2 times 3? It's 6. So I know that 2 and 3 both go into a 6. So if I multiply 2 by 3, I'll get 6. Now if I multiply 3 by 2, I'll get 6. Same sort of argument here. If I multiply equation 4 by the number that's in I2, in the second equation, i.e. 2, I'll get the same answer as if I multiply equation 3 by the number that's in front of I2 in that equation. So that sort of thing will always work. So if I multiply equation 4 by 2 and equation 3 by 5.4, I'll then get two further equations where hopefully I2 will be the same. See if you can carry on from there and work it through, but I'll carry on myself. So equation 2 multiplying by 2, 10.8 I2 minus 4 I1 equals 24. Let's call that equation 5. Multiplying equation 3 by 5.4, I get 11.88 I1 minus 10.8 I2 equals 27. Let's call that equation number 6. And now you can see that I2 is the same in both equations. So now I can eliminate. Notice one's positive and one's negative. See if you can carry on from there and calculate I1 and then substitute I1 back into one of the original equations to find I2. I will carry on though from here. So adding, because one's positive and one's negative, I add equation 5 to equation 6 and I get 11.88 plus minus, so that's minus 4I1, so that's 7.88 I1, adding 10.8 I2 to minus 10.8 I2 is gone, equals, adding 27 to 24, I get 51. So now dividing both sides by 7.88, I get my value for I1. 51 divided by 7.88, which equals 6.47 amps, because it's a current, to 3 significant figures. And that's the answer in the text. So now we can plug that value for the current back in, I1, back into, say, equation number 1, right at the beginning, to find out what I2 is. See if you can carry on and finish from there.